Hello everyone, I am Arnab Mishra and today I am going to talk about history of AI. Imagine going back to 1950s and telling a scientist that one day machine will be able to understand language, play chess better than humans, recognize emotions and communicate with us. It might sound like science fiction, but the fascinating thing is the dream of artificial intelligence is not new. Long before ChatGPT, Siri, or self driving cars, scientists were already asking one fundamental question: can machine think? But today, I want you to take through the history of artificial intelligence, not just as a story of technological progress, but as a story of ambition, failure, and patience. The idea of intelligent machines was first popularized through science fiction. Characters like Tin Man from The Wizard of Oz and the humanoid robot in the Metropolis introduced people to the possibilities of artificial beings that could somehow imitate humans. But eventually, this moved from fiction into science. One of the most important people in this transition was Alan Turing. In 1950, Turing asked a simple question: if humans use information and reasoning to solve a problem and make decisions, why couldn't machine do something similar? His paper on computing machine-learned intelligence explored how we might build an intelligent machines, and importantly, how we could test whether a machine was actually intelligent. So the foundation of AI was not originally about making robots look like humans. It was about something much deeper. Can a machine imitate human thinking? The reading described this as one of the key intellectual foundation of modern AI. But there was a problem. The computers of the time weren't simply enough powerful. Before 1949, computers could execute commands, but they couldn't properly store them. And in the early 1950s, computing was incredibly expensive. The reading notes that leasing a computer could cost as much as 2 lakh dollar a month. So a dream of AI exists, but the technology needed to make the dream possible didn't exist. Then came a major turning point. In 1956, researchers gathered at Dartmouth Summer Research Project on AI. John McCarthy, Mavrin McKinsey brought researchers from different fields together to discuss about AI. And this is particularly important. The term AI was coined at that event. One of the early demonstrations was a logic theorist, a program designed by Alan Newell, Cliff Shaw, and Herbert Simon to imitate human problem solving. The Dartmouth conference didn't solve AI. In fact, researchers couldn't even agree on standardized methods, but they share one powerful belief that AI was achievable, and that belief helped drive the next 20 years of research. From 1957 to 74, computers became faster, cheaper, capable of storing information. And programs such as General Problem Solver and ELIZA demonstrated that machines could perform tasks associated with problem solving. Government agencies such as DARPA began funding AI, and expectation became enormous. In 1970, Mavrin McKenzie predicted that within just 3 to 8 years, there would be a machine with general intelligence of an average human being. But that prediction didn't come true. The researchers discovered something very important. Demonstrating that a machine could perform a particular task was very different from creating a human intelligence. Machines still struggled with natural language, abstract thinking, and self recognition, which human can do. And the biggest problem was the computation power. The computers couldn't simply store and process enough information. As expectations fell, funding also fell. AI research slowed dramatically for about a decade. This period began what is often called an AI winter. But AI didn't disappear. In 80s, AI revived itself with better algorithm and funding. Researchers such as John Hopfield and David Rumelhart helped popularize deep learning techniques that allowed the computer to learn from itself. These systems attempted to reproduce the decision-making process of an expert. For example, an expert could provide answers about how to respond to different situations, and the computer could use that knowledge to provide advice to non-experts. But once again, AI experienced setbacks. The Japanese government invested around $400 million in its fifth generation computer project between 1982 and 1990. Many of its ambitious goals failed, and funding eventually stopped. Yet, something interesting happened. Even without the same level of government funding and public excitement, AI continued developing. And 1990s and 2000s brought some landmarking achievements. One of the famous achievements was in 1997 when IBM's Deep Blue defeated world chess champion Garry Kasparov. This was more than a chess match. It became powerful demonstration that computers could perform extremely complex decision-making tasks. Speech recognition was also making progress, and robots demonstrate abilities to recognize emotions, and actually recognizing it and curing it. So what changed? According to a reading, one major factor was computing power. The problem that had limited AI decades later, insufficient storage and processing capacity, was becoming less restrictive. The reading connects to this to Moore's law, the idea that computer memory processing capabilities grow rapidly over time. In other words, AI wasn't necessarily becoming intelligent overnight. The machines were finally becoming powerful enough to use the techniques researchers had been developing for years. And this will bring to another major change: big data. Today we can collect enormous amount of information, far more than any individual could process. AI can use this data to identify patterns and learn, particularly when combined with massive computing power. The reading points to applications across areas such as technology, banking, marketing, and entertainment. And then we arrive to future. The reading anticipated language-based AI, real-time translation, driverless cars, and eventually the possibility of general intelligence, a machine capable of surprising human cognitive abilities across tasks. But here's where the story becomes bigger than technology. If machines become increasingly capable, what responsibilities should humans have towards the system we create? What should machines be allowed to do? Who should control them? And how do we make sure technological progress doesn't move faster than our ability to deal with consequences? The reading ultimately argues that AI future isn't a technological question, it is also the question of policy, ethics, and human responsibility. So, when we talk about AI today, we shouldn't think that we are witnessing the beginning of the story. We are witnessing the latest chapter of a story that begins decades ago. And perhaps the most important lesson from the history of AI is this: technology may advance quickly, but turning technological possibility into responsible progress is a human task. Thank you for watching, and I will keep uploading videos like this. Please now, please share your comments below and suggest how could I improve better in my speech and the video you want in future. Thank you very much.